Hello and welcome. In this video, we're going to use the coordinate plane to talk about area and perimeter of polygons. Our goals are that we can find a perimeter of a polygon and that we can find an area of a rectangle or a triangle within the coordinate plane. Let's go ahead and jump in. Perimeter and area as a whole aren't new topics for us. We know that the perimeter is the length or the distance around a shape, and we know that the area is how much space that shape takes up. We have learned in previous classes about finding the perimeter and the area of a triangle. So the triangle would be just the length of each side, A, B, and C added together. And the area of a triangle is 1/2 base times height. We know that a square, which is just a type of rectangle, has 4 sides that are the same length. So the perimeter is 4 times that side length, and the area is the side length squared. Similarly, a rectangle, which has 2 sets of equal sides. So the perimeter is twice the length plus twice the width, and the area is the length times the width, or the base times the height. The component that's new here is we're going to actually throw these shapes into coordinate planes, and we're going to have to use distance and length to be able to identify the portions or the side lengths that we need to find the perimeter and area. So let's go ahead and look at some examples. Okay, before we get into the perimeter of these 2 polygons, I'm going to have you pause the video and go ahead and plot and connect the points so that you can see the shapes that we're looking at. There we go. Now, for some of these shapes, we can actually just count the length using the axes. We could also compute it using the distance formula. But let's go ahead and find BC, the length from B to C, just by counting. So 1, 2, 3, 4, 5. BC has a length of 5. We can find AC by counting as well. 1, 2, 3, 4, 5, 6. AC has a length of 6. So we know that we can find AB using the distance formula or the Pythagorean theorem. That's going to be 6 squared plus 5 squared inside that square root. 6 squared is 36, and 5 squared is 25. So AB is going to be the square root of 61. So if we're trying to find the perimeter of triangle ABC, we would get 5 plus 6 plus the square root of 61, or we would get 11 plus the square root of 61. And there we have it. Why don't you go ahead and pause the video, see if you can find the length of the 2 sides that you can count, KL and MN, and then see if you can use the Pythagorean theorem to find the length of the other 2 sides. Remember, they're going to be the same. Then unpause the video and see how you did. All right, hopefully you had time to work that out. We know that KL and NM or MN are going to be the same length, and we can just see that. 1, 2, 3, 4, 5. They are both equal to 5. Then we need to find the length of NK or KN, which is also going to be the same as LM. We can find that by counting their horizontal and vertical components. So this is 1, 2, 3, and this is 1, 2. So Kn is going to be the square root of 3 squared plus 2 squared, which is going to be the square root of 9 plus 4, or the square root of 13. Now, when we find the perimeter of KLMN, we're going to say 5 plus 5 because there's 2 sides, or we could just say 2 times 5 plus 2 times the square root of 13, or times plus root 13 plus root 13. So the perimeter of KLMN is going to be 10 plus 2 root 13. Since we're talking about perimeter, we're going to use units, and since these problems don't actually have units, we're going to use the word units because perimeter would be in some units, feet, inches, boxes in this case, but it would be units because we're adding together all the side lengths, and that's going to be different when we look at area, which is what we're going to do now. All right, again, before we start talking about area, go ahead and pause the video to plot these 2 shapes, then unpause the video to make sure your shape looks right. All right, there we have our shapes. So in order to find the area of a triangle, we need to find the length of the base, which we can actually calculate. In this case, the base, instead of calling it B, I'm going to go ahead and call it FE, but then I'm going to make a little note to us. This is the base of our triangle. We can count that. 1, 2, 3, 4, 5, 6, 7, 8. The length of the base of this triangle is 8. And then we need to find the height of this triangle, which we can actually draw a point here to give us our altitude, and our altitude is going to give us our height, which is basically just asking us how far is it from the bottom of the triangle to the very tip top of the triangle, and I am going to call that H. So the height of this triangle we can also count 1, 2, 3, 4, 5, 6. The height is going to be 6. So the area of triangle DEF is going to be 1/2 the base, which is 8, times the height, which is 6, which is going to be half of 8 is 4, and 4 times 6 is 24. So 24 is going to be our area. Now 8 and 6 both are in some form of units, and when we multiply those units together, we're going to get units squared for our area. So with perimeter, our final answer was in units, or feet, or inches. In area, our final answer would be in units squared. Feet squared, square yards, square inches. Go ahead and pause the video and find the area of the rectangle. So we're going to find the area of rectangle FGHJ on your own. Then unpause the video and see how you did. All right, area of a rectangle, we need just to know the length of each side. So this has a length of 3. And the other side has a length of 4, so we're going to multiply those two things together. Again, 3 units times 4 units is going to give us 12 units squared, or 12 square units. And there we have our area of the rectangle. Now, it is possible that we can just count as we did for some of these, but sometimes we also might have to use the distance formula, which we learned in 5.1. Let's look at one more example together. All right, in our diagram, we have 2 triangles that are making up a larger quadrilateral, a 4-sided figure here. We're being asked to find the area of triangle ABD and then the perimeter of triangle BCD. So let's start by finding the area of triangle ABD. So let's first identify which one that is. ABD is this triangle, which is a right triangle. I can tell because right here, these two have perpendicular slopes. So we can count the length of AB, which we need because that's going to be our height. 1, 2, 3, 4, 5. AB has a length of 5. We can count BD, which is going to be our base, which has a length of 1, 2, 3, 4, 5, 6. So the area of triangle ABD is going to be 1/2 of 5 times 6, or half of 30, which is going to be 15 units squared, or 15 square units. I'm going to encourage you to pause the video and find the perimeter of triangle BCD on your own. Not the area, just the perimeter, and then unpause the video and see how you did. All right, in order to find the perimeter, we need to know 3 lengths. We need to know the length of BD, we need to know the length of BC, and we need to know the length of CD, and then we can add all of those together to get our perimeter. Well, on problem 5, we already found the length of BD. That length was 6. To find the length of BC, we're going to create a right triangle here. This has 1, 2, 3, 4 by 1, 2, 3. And we can do the Pythagorean theorem to find the missing side, or if you notice, this is actually a Pythagorean triple. So BC is equal to the square root of 3 squared plus 4 squared. So BC is the square root of 25, which is 5. If you know that Pythagorean triple, then you don't actually have to show that work. And then if we look at CD, we're going to have the same situation here. This is 3 and this is 4, so we're definitely not going to re-show that work there because that work will look just like it did for BC. So the perimeter of triangle BCD is 6 plus 5 plus 5, or 16 units, and not units squared because we're just adding together the length, so just 16 units. Let's go ahead and wrap up this video. All right, in this lesson, we took what we learned in 5.1 about midpoint and distance and finding those in the coordinate plane, and we tied it back to something that we learned a long time ago in previous courses about area and perimeter with geometric shapes. We found the area and perimeter of triangles and rectangles, and we found the perimeter of other polygons as well. I encourage you to write down any questions you have, and I look forward to supporting you on this. Thanks for listening.